Hey guys, we're going to be continuing here with Chapter 8, Section 5, talking about transformations and similarity. So here's what we're going to be focusing on today. To describe a sequence of transformations that maps one figure onto a figure that is similar. And then also to determine whether two figures are similar by using a sequence of transformations. I think I got a minor mistake on here. This is 6. I changed the words, but that's 8.6. My apologies. Let's keep going. All right, so it says determining similarity using transformations. It says use the zoom and swipe features on your smartphone to enlarge and then move an image of a bee on the screen. You probably didn't even know that you were doing geometric transformations when you do that kind of stuff, but you are. Describe the sequence of transformations that maps the original image of the bee onto an image that is similar. So how do I get from this picture to this picture with this one in the middle? So the first thing is you do that little finger thing where you open up and it makes the picture bigger. We need to figure out what is that dilation. So one way to do that would be to measure, where you would use a ruler. So we'd pick something that's on this image as well as this image that we could measure. And I'm going to say the length between the two arms. So here I would have some type of particular number. You would do this with a ruler. And then I would measure this and I'd have some type of number. And if I had a ruler that I could put on my screen, you would see what I end up finding is that this number, to get to this number is 3.5 times larger than that. So step 1 is going to be dilate 3.5. All right, or an enlargement, we'll dilate 3.5, 3.5 scale factor, let's say it that way. So dilate 3.5 scale factor. And then the next thing you notice is that you don't have the full picture of the bee, so it looks like to get from this to this, we're sliding that bee over. So then we just say translate to the left. Because we don't have like a coordinate plane or anything to describe it with numbers, so we just use the directions that we all know here. All right, so dilate 3.5 scale factor and then translate to the left. That's all you're really doing is how can I get from this to this using different transformations as my description. So here's one for you to try. Go ahead and pause, and the answer will be up in 3, 2, 1. All right, so that's what I got. You might have something a little bit different. You might have said translate right, then down. You might have said dilate and then translate. There's different ways to look at this, and I got an example of that kind of shows that line of thinking here in just a second. But before we get to that, this is just how I feel sometimes. I don't like morning people or mornings or people. Gotta love Grumpy Cat. He's awesome. All right, so determining similarity, it says determine whether triangle ABC is similar to ZYX. Explain your reasoning. There's more than one way to look at this. So instead of going through and copying this out, I got a couple examples to kind of walk you through. So make sure that you're paying attention here. Let me change my color so we can see this. So what you need to know is that there are multiple ways to get from here to here. There's a lot of different ways, so we're going to look at just a couple of them. So I could use a sequence of transformations to prove that this is similar to this. Remember, if I can move this and dilate it, use different transformations to create a figure that lines up perfectly with that, then they are similar to one another. So first step would be one thing I could do is rotate 90 degrees about the origin. So that's taking this and rotating 90 degrees about the origin. Next thing is to reflect over the y-axis. So I would get from here by flipping over the y-axis. And then after that, I would dilate with a scale factor 2. Now I know that that's a scale factor 2 because this has a side length 3 and this has a 6. So to get from 3 to 6, I would have to use a scale factor of 2. So I can map ZYX using transformations with a dilation so that the triangles are similar. These two triangles would line up perfectly after going through these 3 steps. That's the first way I could get from this to this. Now that's not the only way to do that. Let's take a look at another way. Okay, so I could use side angle side similarity theorem to prove that they are the same. So I know that this right here, well, let's see, angle B and angle Y are congruent because they are right angles. And then I know that AB is 3 and B2 is 2, or BC is 2 just by counting. And I know that YX is 4 and YZ is 6 just by counting. So if I put this side over this side, I get 3 over 2. And then if I put this side over this side, because those are corresponding parts, I would have 6 over 4. And 3 over 2 is equal to 6 over 4, because if I simplify this, I do get 3/2. So here I would be proving that they are similar because of side angle side. I have one side followed by an angle, and then another side where those two sides share a common ratio between them. All right, which incidentally would be the scale factor to this, would be 3/2. So that's a second way to look. I think that might be it for today. Yeah, this is a really short lesson, so hopefully you took good notes, and I will see you all in class.